Hi children, this is Suvarna teacher. Children, in this video we are going to demonstrate types of waves and their propagation. Take a slinky. It is a spring-shaped toy which can be extended or compressed very easily. It is very flexible and can be put into many shapes easily. You can send continuous waves on a slinky. Lay it down on the table on the floor and ask a friend to hold one end, pull the other end to stretch the slinky, and move it to and fro along its length. You will see alternate compressions where all the springs and all the loops come closer, and rare fractions where the loops are somewhat little bit a distance. This is similar to the pattern of varying density produced in a medium when sound passes through it. So, through this slinky, we can easily understand the compressions and the rare fractions. And compression is the point where the particles, density of the particles is more denser, and rarefaction is the place or it's a portion where the density of the particles is less. So here a compression and a rarefaction, and compression and rarefactions follows throughout the medium, and thus the wave propagate. This is known as longitudinal wave. Children, let us have a look of transverse wave also. Perform the activities of sound propagation through this ice cream sticks also. You can clearly observe the longitudinal waves, the propagation of the vibration of particles is along the wave, and we can also observe when we twist this model, we can have the nice combination of transverse waves. So clearly you can observe these are all the transverse waves we can observe really. So the peak or the highest displacement of the particles along the from its mean position is called crest, and the below the mean position it is called trough. So transverse wave is a combination of crest and trough, crest and trough. So one crest, one trough, one crest and one trough. This wave travels perpendicular to the wave propagation. Children, you observe carefully. We can have the peak and the depth. So the peak one is known as crest and the depth one is known as trough. So here let us see one more time the demonstration. So this is called longitudinal waves. In this we can see compressions and rarefactions, and when we twist this model it can produce the formation of transverse wave. And sound waves are longitudinal waves you can observe through this video.
Sound is a vibration that is moving through a medium. When we strike a bell, it will begin vibrating. These vibrations will cause movements to the nearby air molecules. The vibration of molecules nearest the bell will cause neighboring molecules to vibrate, which in turn will cause their neighboring molecules to vibrate. In this way, the vibrations will spread out from the bell in the form of waves. If we happen to be in the range of these waves, we'll hear the sound emanating from the bell. Meanwhile, the sound waves will continue spreading out until they lose their energy. Sound requires a medium to travel through, meaning molecules or particles are necessary to carry the sound wave. The vacuum of outer space has no molecules, and so sound waves cannot travel through space or in a vacuum. The propagation of sound won't be the same in all media. Let's look at this by comparing how sound propagates through gases, liquids, and solids. In a gaseous medium, such as the air around us, the molecules will be far apart from each other. If sound waves begin in the air, they will take some time to cause vibrations in the surrounding air molecules. Compared to gases, the molecules in liquids, such as water, will be a bit more closely arranged. Because there are more molecules to vibrate, sound waves require less time to move through the molecules of a liquid.
Okay, as we know that sound waves are longitudinal, as we have seen, when a sound wave passes through air, the layers in the medium are alternately pushed and pulled. Thus, the particles of medium move to and fro along the direction of propagation. Therefore, sound waves in air are longitudinal. Thank you children for watching this video.